Ever catch that sharp, almost metallic smell in the air after a big thunderstorm? Sometimes people say that's ozone, but what is ozone, really? Yeah, and is it always, good for us? Today on the deep dive, we're focusing right in on this molecule. It's kind of intriguing, but often misunderstood. Our mission, pretty straightforward. Figure out what ozone is, what the EPA says about how it impacts our health, and also cut through some of the hype around those ozone generators people sell as air cleaners. We've got three key sources lined up: the EPA's paper on health effects of ozone in the general population, the official regs on the maximum acceptable level of ozone, and another EPA piece on ozone generators that are sold as air cleaners. We know you want the key info, fast and thorough, without getting totally swamped, so let's just dive right in.
Okay, let's start with the basics. What is ozone? Well, like our sources say, ozone O3, it's a very reactive gas. Think of it like supercharged oxygen. Regular oxygen is O2. This has 3 oxygen atoms. And what's really interesting right away is that it kind of has this dual personality. Way up high in the stratosphere, it forms the ozone layer.
Yeah.
Super important. Protects us from UV rays.
Right, the good ozone.
Exactly. But then the same molecule can also form much lower down in the troposphere. That's the air we're actually breathing.
Ah, okay. So the same stuff that helps us way up there can be a problem down here. That seems pretty key.
It really is.
So how does this ground level stuff actually form?
Right. So ground level ozone, it's made through what are called photochemical reactions. It's like you need certain ingredients and a catalyst.
Yeah.
The main ingredients are volatile organic compounds, VOCs, and nitrogen oxides, OVRX.
Okay.
When these mix together and you add heat and sunlight, boom, you can get ozone.
Usually associated with hot summer days, right? Smog alerts and all that.
Yeah. Typically, yes. But here's something interesting this sources mention. In some higher altitude areas out west, where you have snow cover, but also significant VOC and NOx emissions, dot ozone can actually form even in the colder months.
Wow. Okay. Didn't know that. So where do these ingredients, the VOCs and NOx, actually come from? Is it just like cars and factories?
It's more than just that, yeah. The sources give a pretty good list. For VOCs, think chemical plants, gas pumps.
Oh, you're filling up.
Exactly. Also, oil-based paints, auto body shops, even print shops using solvents. And then NOx, that's mostly from high-temperature combustion, so power plants, industrial furnaces, boilers, and yes, motor vehicles too.
Gotcha. So it's kind of everywhere, not just heavy industry.
Yeah.
Even everyday things contribute.
Pretty much.
So that idea that high ozone is only a problem in big, smoggy cities, that's kind of a myth then.
Absolutely. Yeah, while the initial reaction might happen more in urban areas with lots of those precursors, dot ozone and the chemicals that form it can get blown around by the wind, sometimes hundreds of miles.
Oh, what?
So rural areas downwind, they can definitely get high ozone levels too.
And does it peak at a certain time? Like midday?
Often in the afternoon, yeah, when sunlight's strongest. But it really depends on weather patterns, location. Sometimes those downwind areas see peaks later, even into the evening.
Okay. So we're breathing this stuff. How does the exposure actually happen? And what happens once it's inside us?
Well, the main way is just breathing ambient air that contains ozone, right? The total amount you breathe and your cumulative dose depends on the concentration in the air, obviously, but also your breathing rate, your minute ventilation.
So like if you're exercising versus just sitting.
Exactly. Someone running hard outdoors on a high ozone day is going to inhale a lot more ozone than someone sitting inside. And speaking of inside, indoor ozone levels are usually lower than outdoors, typically like 20 to 80% of outdoor levels.
Why the range?
Depends on ventilation, how much outdoor air is getting in, AC systems, but also if there are indoor sources of chemicals that react with ozone.
Okay. And once it's in our lungs, it's not just passive, right? It's actually doing something.
Oh, definitely. Ozone is quite reactive. And unlike some other pollutants, it doesn't dissolve super easily in water.
What does that mean for the lungs?
It means it can get deeper into your respiratory system. Once it's down there, it dissolves in this thin fluid layer lining the airways, the epithelial lining fluid, or ELF. And in that fluid, it reacts really fast with biomolecules.
Reacts how?
The thinking is it creates free radicals and other oxidant species, and those then interact with the airway cells, immune cells, even nerve receptors there.
Okay, so that leads to the health effects people feel. What are those immediate short-term things?
Yeah, the most common thing people report is difficulty taking a full deep breath. Like you can't quite fill your lungs all the way.
Okay.
You might also get coughing, a scratchy or sore throat, maybe chest pain or discomfort, especially when you try to breathe deep.
Tightness, wheezing?
Yep. Chest tightness, wheezing, shortness of breath. Those are all pretty common symptoms.
Does it last long?
The good news is usually not. These effects are generally reversible. Typically within a few hours, almost always within, say, 48 hours after you stop being exposed.
And what's actually causing that feeling, that difficulty breathing deep? What's the mechanism?
Well, the current science points towards stimulation of nerve endings in the airways, specifically things called C fibers. These nerves get stimulated, send signals up to the brain via the vagus nerve, and that seems to inhibit your effort to take that really deep breath.
So it's like your brain is stopping you from inhaling fully.
Kind of, yeah. It's mainly described as a restrictive effect. You can't fully expand your lungs. There might be a little bit of airway narrowing and obstructive component too, but the restriction seems key.
And that shows up in lung function tests.
It does. You see reductions in measurements like FVC, forced vital capacity, and FEV1, forced expiratory volume in 1 second.
Which would explain why it's harder to exercise hard when ozone is high.
Exactly. Your maximal exercise capability can definitely be limited. And interestingly, the body might try to adapt by making you breathe faster but shallower.
A protective thing, maybe?
Potentially, yeah. Trying to limit how deep the ozone gets.
So beyond just feeling it, there's actual stuff happening down at the cellular level too, right?
Oh, absolutely. Ozone and its reaction byproducts, they injure the cells lining the airways, the epithelial cells. This initial injury kicks off a whole cascade of events. Scientists can actually see this using a technique called bronchoalveolar lavage, BAL.
What's that involve?
It's basically like a careful washing of a small part of the lung to collect fluid and cells. And studies using BAL after ozone exposure show clear signs of inflammation.
Like what?
Redness, an increase in certain white blood cells called neutrophils coming into the airways. You also see signs of cell damage itself, higher levels of an enzyme called LDH, lactate dehydrogenase, which leaks out of injured cells.
And the inflammation that involves signaling molecules.
Right. Those injured cells release things like cytokines, prostaglandins, leukotrienes. These act like signals calling in more inflammatory cells.
That sounds pretty significant.
Mm-hmm.
Are there other documented effects at that level?
Yeah. The sources also mention things like increased obstruction in the very small airways, decreased integrity of that airway lining.
Which could let other bad stuff in more easily, like allergens.
Potentially, yeah. If the barrier is weakened, maybe things like allergens or particulate matter could get through more easily. Also, increased airway reactivity, meaning your airways might overreact to other irritants, and even decreased effectiveness of certain immune cells called alveolar macrophages.
Those are the cleanup crew, right?
Sort of, yeah. They engulf foreign particles. So if they're less effective, that's not good.
Does the damage stick around?
After a single short-term exposure, usually things start to resolve over days to weeks. The damaged cells get replaced, inflammation goes down, and the airway usually gets back to how it was before.
Okay. Now, the EPA report mentioned something important. People react very differently to the same amount of ozone. Why is such a big range in response?
That's a really key point. Yeah, the variability is significant. Some people might barely notice anything at ozone levels that cause real problems for others. And what's interesting is individuals tend to be consistent. If you're a high responder, you'll likely be a high responder next time too. Same for low responders.
Does anything explain why someone is more or less sensitive?
Well, age and BMI body mass index play a small role. Younger adults tend to react more than older adults, and people with a higher BMI also seem a bit more sensitive. But those factors only explain a fraction of the variability.
So it's not just age or weight. What else is going on?
It seems the nerve-mediated lung function response, that difficulty breathing deep, isn't necessarily correlated with how much cell injury and inflammation happens.
Huh. Different mechanisms.
Looks like it, yeah.
Yeah.
Suggesting different pathways are involved. There's also some weak evidence, maybe vitamin C or E supplements might slightly reduce the lung function hit. And NSAIDs like ibuprofen might reduce symptoms and lung function changes in people without asthma, but it's complex, different effects in asthmatics. Inhaled steroids have been shown to reduce that influx of neutrophils in people with asthma after ozone exposure. Ultimately, it likely comes down to a mix of environmental factors and our individual genetics. Animal studies show genetic links to inflammation, and there's some early evidence suggesting certain gene variations in humans might play a role too.
Okay, shifting gears to something more serious. What are the link between ozone and mortality? People actually dying?
Yeah, the epidemiological evidence here has gotten stronger over time. Both short-term spikes and potentially longer-term exposure to ozone seem linked to an increased risk of daily mortality. There was a big study, Bell et al., from 2004, across 95 U.S. communities. They found roughly a 0.5% increase in the risk of dying from non-accidental causes for every 20 parts per billion, or ppb, increase in the 24-hour average ozone level on that same day.
0.5% doesn't sound huge, maybe.
As a relative risk, maybe not. But think about the whole population, and the effect is most pronounced on the day of exposure, with some smaller effects lingering for a few days.
And does it affect everyone equally?
The percentage increase in risk might be similar across ages, but the absolute number of extra deaths is much higher in older adults, just because their baseline death rates are higher to begin with.
Right. Makes sense. So overall, it's a public health concern, even if the individual risk on any given day is small.
Exactly. And this ozone mortality link seems strongest in the warmer months. It holds up even when they look specifically at deaths from heart or lung problems.
Do we know why ozone exposure might increase mortality risk? The biological reasons?
That's still being actively researched. The precise mechanisms aren't fully nailed down, but research is looking into effects on the nervous system's control of the heart, effects on blood clotting, impacts on substances that control blood vessel constriction, things like that.
Okay. Beyond mortality, what other negative outcomes are linked to short-term ozone exposure? Hospital visits.
Yep. Sources show increases in hospital admissions and ER visits for respiratory causes. Even things like school absences have been linked in some studies.
So breathing problems sending people to the doctor or hospital.
Right. There's pretty consistent evidence linking higher ozone to more respiratory illness, especially in warm seasons. This definitely includes flare-ups of asthma and likely COPD too. The evidence might be a bit less clear for other specific conditions, maybe just due to fewer cases, but the overall trend for respiratory problems is there.
And the school absences?
Some studies see a link, yeah. Whether that's directly from more respiratory infections triggered by ozone or other factors, maybe needs more research.
We've talked about all these effects.
Yeah.
But at what levels of ozone do they actually start happening? Is there like a magic number, a safe threshold?
Not really a simple threshold, no. It's more complex. The concentration where you see effects depends on the individual's sensitivity, right?
Mhm.
And also the total dose they get, which, again, depends on the concentration in the air, how fast and deep they're breathing, their minute ventilation, and how long they're exposed.
So exercise makes a big difference.
Huge difference. Someone exercising vigorously for hours could definitely feel effects at lower ambient concentrations than someone resting indoors briefly. And again, more sensitive people react at lower levels. Kids, for instance, seem to experience similar lung function drops as young adults, but might report fewer symptoms at lower levels.
What about studies done outside the lab, in the real world?
Field studies often show effects at lower average levels than controlled chamber studies. That could be because they include more sensitive people, or people are exposed to mixtures of pollutants, or the exposures are longer.
Any specific numbers from those?
Well, some field studies suggest lung function effects in active kids with asthma and maybe athletes even below an 8-hour max of 80 ppb. And ER data has suggested increases in asthma attacks above maybe 110 ppb for a 1-hour max, or maybe 60 ppb as a 7-hour average, again in sensitive groups.
And mortality.
Some studies have detected mortality effects even when the 24-hour average ozone is below 60 ppb.
Okay, what about the long haul? If someone is exposed repeatedly, maybe living in a higher ozone area, does that lead to permanent problems?
That is a really critical question, and honestly, the answer for humans isn't completely clear yet. We do know that if you get exposed daily for several days, some of those immediate nerve-mediated effects, the lung function drops, the symptoms, they can actually lessen. It's called attenuation.
Oh, so you adapt.
You adapt in terms of feeling it as much, perhaps, but, and this is crucial, the underlying injury, inflammation, and repair processes in the airways, those continue happening during repeated exposure. Markers of inflammation stay elevated.
So even if you feel better, the damage might still be occurring.
That's the concern, yes. And maybe function in the small airways stays depressed while the inflammation is ongoing.
What about animal studies? What do they show long-term?
Animal studies are pretty consistent. Long-term exposure to ozone, usually at levels higher than typical ambient air, can lead to persistent structural changes in the airways. Things like changes in mucus cells, thickening of the airway walls.
And could those changes be linked to chronic disease?
Some researchers think these changes could potentially play a role in developing or worsening chronic lung diseases, possibly including asthma.
But we don't see that same clear link in human studies.
It's much less clear in humans, yeah. The epidemiological evidence is, well, inconclusive. Some studies looked cross-sectionally.
Meaning, like, a snapshot in time.
Right. Comparing people who grew up in high ozone versus low ozone areas. Some suggested slightly lower lung function in young adults from high ozone areas, but other studies haven't found the same thing. It's not consistently replicated.
And long-term studies following people over time.
Some longitudinal studies have hinted at maybe a link between long-term ozone and developing asthma, especially in certain subgroups, like kids who exercise a lot outdoors. But again, these findings haven't been consistently confirmed either.
Why is it so hard to study this in people?
It's really challenging. People move around, so estimating their long-term exposure is tough. Plus, we're exposed to a mix of pollutants, not just ozone. Teasing out the specific effect of ozone over decades is just very difficult.
So where does that leave us?
Well, even though the human evidence is inconclusive, the fact that we know repeated injury cycles happen, plus the animal findings, it suggests, prudence. It's probably wise to try and avoid repeated short-term ozone exposures, especially for young children whose lungs are still developing.
Okay, this all leads us directly to those ozone generators marketed as air cleaners. Given everything we've just heard about ozone being potentially harmful, these devices seem, well, counterintuitive. What's the EPA's take on them?
The EPA is really unambiguous about this. They state very clearly, and no federal agency has approved these devices for use in occupied spaces, period. Manufacturers often tout ozone's reactivity, that extra oxygen atom wanting to react with things, as the reason it cleans the air.
Right, breaks down pollutants.
That's the claim. But the EPA points out that the very same reactivity that lets it interact with chemicals also lets it react with and damage our lung tissue when we breathe it. It can cause the exact same symptoms we talked about, worsen asthma, etc.
What about those fancy marketing terms they use? Activated oxygen or pure air?
Yeah, the EPA calls those out as potentially misleading. Ozone is toxic. It's not the same as the oxygen we need. And they emphasize that multiple agencies have set health standards to limit ozone exposure. You've got the FDA limit for medical devices at 0.05 parts per million ppm.
Right.
OSHA and NIOSH workplace limits usually around 0.10 ppm. And the EPA's own outdoor air standard is 0.08 ppm as an 8-hour average.
So there's no such thing as good ground-level ozone?
None. It's potentially harmful to breathe. Doesn't matter if it came from a machine or from outdoor smog.
Okay, bottom line then. Do these generators actually work to clean indoor air effectively?
The overwhelming scientific consensus, according to the EPA, is no. Not at concentrations that are safe to breathe. At levels below public health standards, ozone has very little potential to actually remove most common indoor air contaminants.
Manufacturers claim they destroy everything, right? Leaving just CO2 and water.
That claim is just not scientifically accurate, says the EPA. For many typical indoor chemicals, the reaction with ozone is incredibly slow, could take months or years, so it's basically useless for cleaning air in real time. It's not effective against things like carbon monoxide, for example, or formaldehyde.
And sometimes can the reactions actually create new problems?
Yes, that's another major concern. Ozone can react with chemicals already in your home, maybe from carpets, furniture, cleaning supplies, and create new, potentially harmful or irritating byproducts. Things like aldehydes, formic acid. Sometimes the total level of organic chemicals can actually increase.
Wow, okay. What about things like smells or allergens like dust and pollen or mold?
For odors, maybe it reacts with some odor chemicals, but many it won't touch at safe levels. Sometimes it might just mask an odor with its own sharp smell. It definitely doesn't remove particles like dust and pollen. Those need filters. Some units have ionizers, but the EPA notes filters are generally better for particles.
And mold, bacteria, viruses.
Not effective at safe levels. To actually kill germs or mold effectively, the EPA says you'd need ozone concentrations 5 to 10 times higher than the public health standards permit, which is clearly unsafe to breathe. And even then, it might not work well on porous stuff like drywall.
That's pretty damning. What if someone just follows the instructions that come with a generator? Are they safe then?
Not necessarily, unfortunately. Studies have shown that even when people follow the manufacturer's directions, some of these generators can still produce ozone levels way above the health standard.
Why is it so hard to control?
Lots of factors influence the concentration in a room. how powerful the machine is, room size, how much ventilation there is, even what materials are in the room that might react with the ozone. Plus, the output isn't always linear with the control settings, and you definitely can't rely on your nose. You can get used to the smell, or it might be harmful even below levels you can detect.
So if ozone generators are not the answer, what should people be doing for cleaner indoor air, according to the EPA?
They really push proven methods. Number one, source control. Get rid of the source of the pollution if you can, or reduce it.
This makes sense.
Number two, ventilation. Bring in fresh outdoor air to dilute and remove indoor pollutants. Open windows, use exhaust fans. And number three, proven air cleaning methods. That means using things like air purifiers with effective filters, HEPA filters for particles, maybe activated carbon for some gases.
Right, things that are actually tested and shown to work safely. Now, that second source we mentioned, the actual regulation on the maximum acceptable level of ozone, that sounds like it would back this up pretty strongly. What are the key points from that FDA regulation?
Oh, it absolutely does. That regulation, Title 21 CFR, it's very direct. It calls ozone a toxic gas with no known useful medical application at safe levels. It explicitly says the levels needed to kill germs are far higher than people or animals can tolerate safely.
So no therapeutic use at safe levels.
None. It highlights irritation as the main effect, warns about pulmonary edema fluid in the lungs, which can have delayed symptoms, making symptoms unreliable. And it also mentions olfactory fatigue. You stop smelling it, even if it's still there at dangerous levels.
And what does it say about devices that produce ozone?
This is really clear. Any device generating ozone that results in more than 0.05 ppm in an occupied space, homes, hospitals, offices, is considered adulterated and are misbranded. That's the legal determination.
0.05 ppm, that's a low number.
It is, and it applies to all ozone generators used in those spaces. It also specifically calls out use in hospitals or places with ill people as problematic. And devices must be labeled with their maximum ozone output, equals 0.05 ppm, and the smallest room size where they can be used without exceeding that level.
Any other restrictions?
Yes. It states ozone cannot be used for any medical condition without proof of safety and effectiveness. And crucially, devices cannot be labeled as germicides or deodorizers, even if they produce less than 0.05 ppm ozone.
Wow, so even low-output devices can't claim to kill germs or deodorize based on the ozone.
According to that FDA regulation, correct, it basically reinforces that ozone isn't meant for cleaning air or treating illness in occupied spaces.
So a really consistent message here from both the EPA assessments and the SEA regulations. Ground-level ozone is something to limit exposure to, and devices intentionally creating it for air cleaning in homes are not recommended and potentially unsafe.
That sums it up perfectly. The science and the regulations both point away from using ozone generators in occupied spaces. Stick to the proven stuff, control the source, ventilate, and use effective, safe filtration methods. That's the reliable path to better indoor air quality.
So as you think about the air you're breathing, maybe in your home or office, we really hope this deep dive has given you a clearer picture of ozone. Its complex nature, the real health impacts, and the facts behind the marketing claims for some of these purifiers. It might make you pause and think about what fresh air really means, and maybe look into more reliable ways to make sure your indoor environment is truly healthy. And definitely check out those EPA resources we mentioned if you want to go even deeper.
And maybe one final thought to leave you with. Considering how complex indoor air chemistry can be and how these ozone generators turned out, what other assumptions might we be making about other products or practices we use thinking they're improving our homes or our health? It might be worth taking a closer look at the science behind the claims sometimes.